Hi and welcome everyone. We're going to change pace a little bit and talk about technology and how it redefines the mining life cycle. Maybe to kick things off though, some quick introductions. Alain, can you introduce yourself?
Yes, I'm Alain Zubrzycki. I'm the owner of
Ah,
oh,
can someone fix and unmute Alain's mic, please?
can you hear me? No?
Ah, plan B.
Hello? Okay.
Perfect.
So I'm Alain Zubrzycki. I'm the owner of four small businesses dealing all in geophysics or geology. And CAUR Technologies, the last business that we started, and the whole idea was to take advantage of the new technologies available in AI and computational power, and also even IoT. So that's me, and I guess I'll let you present yourself.
So I'm Melanie. I'm the Global Director of Project Development at Hatch. As part of our metals team, I look at metals projects, the full cycle from concept design all the way through execution into operational support, and we do closure and things as well. But I'm looking at anything from the mine all the way through to a final product, whether that's concentrate or a wire or a battery, but anything in that whole space. So it's a pretty broad perspective. All right, and so we're here to talk about the life cycle, and the first part in the life cycle, I think, is the exploration side. So maybe, Alain, I'll let you start. What are you seeing in that exploration field, and how are things changing?
Well, thanks for the question. I guess the answer to that is why we started our company, CAUR Technologies, because we saw that with new, let's say IoT, AI algorithm, we would be able to actually be able to manufacture instruments that would be able to get data in the field much faster than what was actually available in the last few years. So we can talk about data acquisition, we can talk about data treatment. In general, I would say that data acquisition can be done nowadays 10 times faster than what was available in the past. So let's assume you have a general IP survey. I'm trying to compare bananas with bananas, but it's never perfect. So let's say you have an IP survey that has 200 line kilometers that you want to carry out in the field. What do you need to do? You need to cut lines. So you need to call people. And one of the reasons why we started the CAUR technology is that we couldn't find anybody to cut the lines. And once the lines are cut, you send a crew of 6, 8 people and they carry out surveys. Maybe they do 2 kilometers a day. So we're talking about 100 days, maybe 120 days, just of field work. So with CAUR technology, what we do is we provide clients with a sensor, 200 sensors. They install them in the field. It has its own GPS. We don't have to disrupt the environment. And we can get the data within, let's say, 20 days. So that's still maybe 5 or 6 times faster than a general, quote-unquote, IP survey, which will give you the similar type of information. Our technology allows to provide like 3D information. So field operations, I think in general, it's not just our technology, but in general, with IoT and the ability to communicate between different instruments without human intervention, that could result into 10 times faster field operations. Now, when it comes to data treatment, you all know that AI is revolutionizing the way people do inversions, the way people even incorporate different constraints into their models. But we did a project about 3 years ago, and it took us like 2 years to accomplish it. The equivalent right now, if you talk to our people, can be done in 3 months. So I think that what is going to be happening is that data treatment will no longer be such an important thing. I even think that large software companies, they're going to have to find another way to do their own business, because right now we do our own software. Well, we do what, agentic programming. So what I see in short, what I see is that we're going to need less specialized people for data programming, and creating complex inversions, and the bottleneck will be data acquisition. So even though we're going 10 times faster and we're going 100 times faster, I mean, the bottleneck will be still data acquisition. So if you have good data acquisition, then yes, you can feed, your data interpretation, but that's going to be the bottleneck. So I still think there's going to be a lot of employment in that area, because we need a lot of copper, we need a lot of minerals. So I don't see, I'm not negative at all about the prospect of employment, especially for field work. I mean, when it comes to very specialized geophysicists doing inversions and that kind of stuff, well, you don't need 10 people. You probably need one person to do the job of 10 or even more, because now you have this agentic programming. So I think that's one of the things that I see happening. That's how we are operating right now. We have 3 people doing the job of maybe 30, 40 people, simply through programming. And field work, now we're maybe 5 times faster than what we used to be. And I think there's going to be a strong tendency toward, I would say, passive techniques in the future. Melanie, maybe you're more at the production side, or maybe you can explain how you see AI affecting.
Yeah, for sure. And it's interesting, you see your workforce getting a little bit smaller, although still a strong need for those expertise. I don't think we've seen that yet in necessarily the project development world. As we look at developing projects, there are lots of places that technology is helping, and AI itself is a big topic these days. And yes, it can be a tool, but it's not a silver bullet that's going to replace project design. So anyone that's been involved in a mining project understands it's a really complicated thing. There's a lot of different parties that come together in this, and bringing in AI could help you do specific tasks right now. And that's very interesting and obviously something to pursue. But if you think of the data sets that are out there and you're trying to design a mine or a processing facility, yeah, there's quite a few out there. There might be quite a few in Quebec, but where do you get that data? How do you train AI to do that? I mean, AI is developed on these large language models. Think of the volume of data that it's been trained on, and we still know there's a lot of mistakes, right? And so those mistakes become a little bit more consequential when you're engineering things and you're talking about safety and the environment in that. So there's a lot of, forward with caution in there, and making sure that we are leveraging where we can and shortening things that we can. But I think overall the life cycles, I don't see them changing too much. I'm not sure the workforce has changed that much. I think people are going to have different skills, though. As an engineer coming into the workforce, being able to work with new technologies and AI becomes a really important thing, and looking for new and innovative ways of doing things. But we still need engineers and bringing them in, and engineers have that ability to do those complex problem solving that I don't think we are there yet in terms of AI just being able to magically design a plant for us.
Yeah, I guess in your field there are a lot of factors. There's like human factor, environmental factors. So the bottlenecks, probably AI will not help at all.
No, I mean, we heard this morning from Grand Chief Picard about the importance of building relationships, right? And You have that opportunity to build relationships with Indigenous communities, and he even talked about companies wanting to move too fast for what they're able to do. Those are things that are on the critical path to developing projects that are outside of technology, right? And those relationships have nothing to do with technology, and the only way to build them and accelerate projects is investing the time in that work, right? So I was reminded last week, I sat in a 2-day workshop with a client talking about a pre-feasibility study, and I'm looking at infrastructure, mine infrastructure, and there's 25 people in the room, and you start talking through all the different components of the project, the geology, the exploration, the environmental parameters, the community, Indigenous engagement. You're reminded very quickly that actually building the physical thing is not necessarily the critical path, right? There's permitting, and we heard from the minister about what they're trying to do to streamline that. There might be enabling projects, we heard a bit this morning, getting enough power to the site that's often outside the hands of the mining company. They're relying on governments and other parties to do that. And so technology is not necessarily helping shorten some of those critical path items and building those relationships.
Thanks. I would maybe add that on our side, one of the things that we're doing, and I think you probably have seen it all, that there are a lot of companies now that have their own predictability models, right? So you take a huge data sets, satellite data sets or governmental data sets, and then you create a map of favorability. So these things are actually pretty powerful. And I would say every model is good. Some of them are better in some areas. Some other models are not as good. But still, that is going to help quite a bit in identifying certain areas of interest for exploration. So if we apply this first layer of information and then we add to that, let's say our technology, which is CAUR technology, which is seismic, but it could be mag, could be any other technique. You add that to that, I think the rate of discovery will be much better. So right now, let's assume that the discovery rate is 1%. So maybe this is going to bring the rate of discovery to 3%. But that's still, it's not a lot, but it's still 300% increase. So I think that's where we are at now. We can go faster, we can be smarter, we can add different technologies, but still at the end of the day, we're still going to be in a situation you have a 3% discovery as opposed to 1%. So you're still not, you're going to need, fantastic geologists. You're going to need great field people. You're still going to need all that to find one mine. So it's I see I don't see robots or AI replacing human beings in the field that quickly. I mean, it can happen, but still the stats are there, like 3%. So that's what I see.
So you're definitely thinking we need more geophysicists graduating from university? Is that what I'm hearing?
I don't know if there.
If we have 3%, or if we triple the number of discoveries, is that?
Well, I think we're going to triple. I think we could triple the number of discoveries with, let's say, the same amount of people right now. That's what I think the technology will allow that. However, the bottleneck will be the field people, because where we have the real increase in power is the interpretation of data sets. So you still need people in the field. So I'm not sure you need geophysicists per se all the time. And I think if we use passive technologies, I think that's where, if we, let's say MAG is a passive technology, gravimetry is a passive technology, but even ambient noise tomography is a passive thing. If you combine these passive technologies, you don't need as many people. So you could do many more surveys than typically you would do. Let's say, again, I have nothing against IP. We manufacture IP equipment, and it's a great technique. But I see the future as being more more and more people, more and more companies using passive technologies as they're getting better.
Do you see any way where we're going to get away from having to drill less?
No, I think no.
No. I mean, geologists always want to drill more core. That's what I've learned.
Yeah.
But do you see a time where we can, is there anything out there where we see maybe we're going to be able to spend less time drilling, more time using other technologies to validate the resource?
Well, for sure, if you have better targeting, you're going to be, drilling less. And also now there are some technologies that allow you to, scan the core, core scanners. But very often what I find or what I hear is that, people core the scan, but they don't have anybody to do the interpretation. They have tons and tons of data, but they don't know what to do with it. And even if they have this AI, they don't really know how to use the AI to better target. So we're still, the AI is not optimized at all, I think. Mm-hmm. And I know there are some companies that are really striving to optimize the exploration profile. I don't know if I can name them, or I think it's public, but Agnico Eagle is really looking at creating a very smooth stream of exploration in order to minimize drill holes and use as much information as possible. But I don't think this has been done overall, and I think Agnico will, if they succeed, they're going to remain the top gold producer in terms of cost. So I think it's a smart move on their side.
Okay. But the other thing we invite you guys to please ask us questions. I think there's 2 microphones out in the audience as well. So if anyone, I see someone moving to a mic. Sorry, it's a little bit bright, so it's hard to see, but go ahead. Can we get the mic on?
I can try to just talk louder.
All right.
Thank this amazing presentation. So the work where I'm in is the nexus of Indigenous relationship building, exploration, and capital markets investment. So one of the things that I liked that you said, Alain, was bottlenecks, and how can the technology that you're effectively using be used to reduce those bottlenecks. And from what I understand, the things that you talked about is there's labor, time, data acquisition, and then data interpretation. So one of the key bottlenecks that I'm seeing in even to get to some of the exploration phases, one of the things you're talking about is like the IP exercise, is the Indigenous consent to be part of that exercise. Mm-hmm. So some of the strategic, I would say, opportunities that exist is Nation X will say to Explorer Y, okay, you can do this study, but I want people from our community to be doing that work. So then it involves, how do you train people to do that work, and how many people would need to do that work? So if I'm hearing it correctly, hypothetically, we could work to train people, whether it's in communities or elsewhere, to use more advanced technology to assess or gather more data if you're doing that kind of like right-of-way analytical work. And the other thing is would your technology not only apply to the exploration data collection, but any other kind of like geographic data collection as well, whether that involved like wildlife, patterns, or anything else like that can give you more regional data collection? And then, third part is, how would you then take that data and solve into the interpretation part from not only a quantitative, but a potentially qualitative way as well, which many Indigenous groups also look at? Thank you.
Big question for you.
Keep track of all the questions. No, I'm just kidding. Okay, one thing that is good about this technology, let's go back to the native people and all things being equal, this technology, is not going to solve the issue with, let's say, the native people, right? If it took 3 months to solve a certain issue with native people, it's probably going to take the same amount of time. However, where I join you is the technology that we have made is very easy to use. And actually, our business model is we send you, let's say, 200 geophones in 2 cases, each one of 100. You install them. There's a GPS on them. You really have nothing to do. You just pick it, put it on the floor, make sure it's well coupled. You turn it on. You walk another 200 meters, you do the same thing. And it's very, very forgiving. So actually, our whole business model is not us going into the field. It's actually, native people doing it, and then they can charge to their clients, for example, the mining company. So we're more than welcome native people or even quote unquote competitors to use that technology. Now this technology is really just to measure seismic waves. However, there are a lot of different ways that you could measure wildlife activities. It doesn't have to be, we're not specialized in that at all, but I mean, you could certainly install like 200 cameras or 200, these are like, these could be considered like movement sensors, seismic. So you could use that. So there's a lot of things we could do, but actually one of the things that we're looking at is partners right now in Northern Canada, where we can, send like 200 geophones and then they do their own survey. And then we could share a participation with them, or if they represent some clients. So yes, I think it's a bit of a revolution because it's easy to do in the field. Very, very easy.
Okay, well, that's interesting. Easy data collection is definitely a big thing, and then it can feed into other models. I can imagine we could do something like that for the biology side of things, although I don't know. As a similar example, one of the things we've done with AI technology, like buses have cameras on them, and one of the things you can do is have that, as it gets to a bus stop, it's recording. And now we can have AI technology that looks at that, analyzes those images and says, hey, this bus shelter needs repair. The glass is broken. Hey, it's missing the garbage can. So we're doing things like that in the infrastructure space. Imagine you could do that for wildlife detection as well. So I don't know, not my area of expertise, but I imagine we could do it on another panel. We need a biologist up here, but I imagine there's a lot you can do with visual AI as well. So certainly being able to send something small like that out and have it placed would be a huge benefit. Do we have other audience questions? Apologies, I can't really see. No? Quiet bunch.
No more questions?
No more questions, okay.
Well, no? Thank you very much.
Oh, we have another one right here. Okay. Oh, follow up.
I think we're going to have a good discussion, both of us, later on. I think.
All right.
Data, once it's collected, is this going to a like a CAUR Technologies, like data farmer database, or if you had like an agreement or a joint venture with a First Nation, potentially in a First Nations owned and operated data center, which is another market that many.
But typically we, the data has to be sent to us, I guess through the cloud, and we do the interpretation. But what we do is that we work with you. For example, we will build for you a 3D model. And then, if you have a geologist working with you, or geologists that are native, then we will be working with you, and then that cube, that 3D model that we build, is yours. So if you bring drill holes, every step of the way you can improve the cube. And so it's not just a map. You remember, like people would just get a map or even a picture now of colors and stuff. So we really give you a 3D geological model, and that's half of our staff are geologists, and one of them is really well, not just one of them, but we have a few of them that are, economic geologists, and they really pride themselves on making sure that what you're getting, you can use. You don't need us, let's put it this way. Once it's in your hands, you can go sell it, you can do you can improve it. There's a lot of things that, so that's easier than, let's say, 5 years ago. That's the point. It's much easier than it used to be. Okay, thank you.
That's a good point in the data collection, making it easy to use, right? So we do see that a lot on the engineering world, especially. There's a lot of pressure sometimes, and just because we can generate data, we do really have to sometimes stop ourselves and say, what are we making this for? Who's going to use it? Why is it being used? What are we interpreting from it? Because it's easy to make a lot of data sometimes, but we got to think about what are we doing with it, and who are those people that can actually take this data and distill it to something that's going to be helpful to move something forward or improve. So it's a good point there. All right. Anything else? Last thoughts? Any last thoughts from you, Alan?
No, thank you.
All right. All right. Thank you, everyone. That
Thank you.
concludes.